Okay, so I wanted to show you on this one. It's kind of hard to determine which one would be the longest side, but if you get the calculator and hit the square root of 65, well, 65 is between 49 and 64. Actually, it's a little more than 64. So it's an 8 point something, 8.1 or something like that. So this the 65 would be considered your hypotenuse. So that's going to be our letter C. So this is our letter C, and then the other one will be our A and our B. Okay. So type it in, a squared plus b squared equals c squared. So we got 4 squared plus 7 squared. Is that less than, greater than, or equal to the square root of 65? 65 and then square. Okay, so the square root and the square, they cancel each other out. So if you have something like 4 to the second power, okay, well, 4 to the second power is equal to 16. And then what's the square root of 16? Well, the square root of 16, that would be 4. Okay. So what I like to think is they just cancel, they undo each other. So the square and the square root cancel each other out, and we left with just 4. So that's what's going to happen here. The square root is going to cancel with the square, and you're just going to be left with 65. So 4 squared is 16, plus 7 squared is 49, and compare that to 65. So 16 plus 49, I think it's 65. So we got 65 is equal to 65. Mhm. So when they're equal to each other, then we have a right triangle. Okay, so it's a right triangle because the sum of the squares of the legs is equal to the square root of the hypotenuse. Okay. So the sum is a right triangle because the sum of the square of the legs is equal to the hypotenuse squared. Let's see. Okay, so let's go ahead and graph these points. Okay, so let's draw them. So we got -2 and 4, -2 and up 4. If you still have trouble with plotting points, just do it on decimals. 8 and 4, 8 and 4, and 6 and -2. So 6 and -2, -1, -2. Okay, and then I'm going to connect this. Okay, so graph it, and it says triangle JKL, so that's where we're going to graph it. So let me also label it. So J is -2 and 4, so this is J. K is 8 and 4, so that's K. And L is 6 and -2. Okay, so for that one, that's what we wanted to do. Consider the sides of the JKL. Describe the triangle as cascading, isosceles, or equilateral. Explain your reasoning. Okay, well, we got to find out the sides. Okay, so some of them are pretty easy to find because they're just on a straight line. So anything that is like, I'm sorry, it's a horizontal line. They're all straight lines. So if you look at the horizontal line, you can just do it by counting. So if you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can also use the number line. If you look at the number line over here on the bottom, you're going from -2 all the way to 8. So from -2 to 0, that's 2, plus another 8, that gives you 10. So this is going to be 10. 10 units. Okay, and let's find out from J to L, how much would that be? Well, to do that, what you want to do is you want to draw another triangle. So you draw a triangle and you label it. That's gonna be your A, that's gonna be your B, and that's gonna be your C. Now we can do that because it makes a right triangle when we're using that when it's graphed. So it's kind of nice in that regard because you know that that is a right angle because you have a vertical line and a horizontal line intersecting, and where they intersect at a 90 degrees or there are perpendicular lines. Okay, so we got 1, 2, 3, 4, 5, 6. So this is 6. Again, you can do that by counting from 4 to 0, that's 4, plus 2 more, that's 6. And from -2 to 6, that's going to be 8. So this is 8. So we got 6 squared plus 8 squared equals C squared. So 6 to the second power plus 8 to the second power. So this is 6 times 6 is 36, plus 8 times 8 is 64. 64 plus 36 is 100. So we're looking at the square root of 100, which is 10. So C is equal to 10. Oh, so we have two sides are the same so far. Yeah. So if you have two sides that are the same, what type of triangle is this? Okay. Now let's find out this side. Now it doesn't look like this is going to be a 10, but let's go ahead and just figure it out. Might as well. So again, we'll draw a right triangle. Okay. And again, now this is going to be our C for this right triangle. So we got 1, 2. So this is 2. And then from -2 to 4, that's going to be 6. So we have 2 squared plus 6 squared. So 2 squared is 4, 2 times 2. And 6 squared is 6 times 6, which is 36. So then we have the square root of 40. So the square root of 40 is about, let's see, 6 times 6 is 36. 7 times 7 is 49. So 36. So it's closer to 6. So about 6.3 or 6.4, one of those two. I'm just kind of just rounding it up. But what I did notice was one side is 10, the other side is 10, and the other side is 6.3. So that makes it an isosceles triangle because two sides, at least two sides are congruent. So this is a, so triangle JKL is an isosceles triangle because at least two sides are the same. Okay. And now we're gonna see, is it acute, is it obtuse, or is it right? Well, let's see. Which one would be the longest side? Well, both sides are 10. So this side is 10 and this side is 10. And this side is the square root of 40 or 6.3. So let's just say this would be C. Okay, just for our, and let's say we think this might be the right angle, or this one could be the right angle. But because this is 10 and this is 10, it doesn't matter. So let's see. If we have 10 squared plus 6 squared, compare that to 10 squared. Is it less than, which makes it which makes the hypotenuse being smaller? Is it greater, which makes the hypotenuse being, okay, the first one is the legs are smaller. This one's the hypotenuse. Let me just work it out. So this is 100 plus 36. So this is 136. Sorry. 136, which is greater than 100. So that means the hypotenuse, it's smaller. And if the hypotenuse is smaller, then it's going to be an acute triangle. So since the hypotenuse is smaller, since hypotenuse is smaller, the triangle is an acute triangle. Yes. Okay. Perfect. And that's it.